Hello everyone. Today we're going to be looking at the sine law, which is one of the rules or laws that we need when we're working with non-right angle triangles. When you're working with non-right angle triangles, you cannot use the Pythagorean theorem or SOHCAHTOA. There are two laws that you use instead, the first one being the sine law, the second one being the cosine law. That means you're going to have to be able to choose between the correct laws. Which one do you use? Well, if you're given, or you can calculate, an angle across from a given side, that's what tells you to use the sine law. And I'm going to show a picture of that in a second. This is what the sine law looks like. It's a over sine A equals b over sine B, and potentially c over sine C. Now, what this means is it actually doesn't matter what the letters are that designate the triangle, and we're going to learn that side lengths are always designated with lowercase letters, and angles are always designated with uppercase letters, and those are always across from each other in the triangle. But your triangle could be labeled X, Y, and Z. It doesn't have to be A, B, and C. All that matters is that these two letters are the same, except one's lowercase and one's uppercase, and these two letters are the same, one's lowercase and one's uppercase. In textbooks, they like to show all three fractions equal to each other, but I don't like to do that because some students will get confused and think that they have to use all three fractions at the same time, and you don't. You only ever use two, but it could be any combination of the three sides. Okay, so it could be sides A and B, it could be sides B and C, or it could be sides A and C. So you're only ever using two fractions with two completely separate letters, lowercase and uppercase versions of them. So let's say you had a question that said, here are a couple of boats. Which boat is closest to port C? Now, I want you to notice that the 80-degree angle here technically doesn't have to be given to you in order to be able to have the condition that you have to be given an angle across from a given side to be able to use the sine law. So let's actually get rid of that 80-degree angle just for a second. I'm just going to move it over here. So let's say this was the original triangle given to you. We're going to need that 80 degree to fulfill the condition of an angle and an opposite side given to us. If you look at which side is given to us here, there's only one side given, and that's the 15 miles right here. That means we absolutely need the opposite angle given to us as well. I want you to notice that we labeled that opposite angle capital C. It is across from lowercase c. I put a little tail here on the C to show that it's a lowercase. Capital A is across from lowercase a, and capital B is across from lowercase b, A, B, C, capitals being the angles, and A, B, C, lowercase being the side lengths. Like I said, notice that the 15 miles is across from my question mark here. I absolutely need that angle in order to fulfill that condition. But because they gave me two other angles, we know that in a triangle, all three angles are equal to 180 degrees, right? So angle C is equal to 180 minus 45 minus 55, and that's what gave us our 80-degree angle. So sometimes it'll look like they didn't give you the conditions to be able to solve with the sine law, but as long as you can calculate that missing angle across from the given side, then you're good. Now, this idea is so important that I call this the Sine Law Key. You need the Sine Law Key to unlock the ability to use the sine law. The Sine Law Key is an opposite side to an angle given to you as numbers, and then you can actually solve that triangle. So we need to actually find lengths A and B to be able to tell which one is closest to C. And when you're solving a triangle, that does mean find all of the unknown sides and angles, okay? but sometimes they're only asking you for one side length. Here we have to calculate 2. So how do we do that? Well, we're going to set up the sine law, a over sine a equals b over sine b, but using the correct letters that we need to actually solve this for each side. So let's say I wanted to solve for side b. The first thing I want everybody to know is that you're always going to put your unknown in this position. Always. Okay? So whatever letter you're looking for, you're always going to put it in the top position here. We know that following the sine law from above, that the bottom here has to be sine capital B, because there's always the same 2 letters, just one's lowercase and one's uppercase. And the uppercase one is always attached to sine because the angle is always attached to sine. So the uppercase letters are the angles here. On this side of the fraction, we're going to put our key, because those are the only 2 numbers that we know. So this has to be little c over sine big C. So this fraction is made up of the key values. And if you can remember that, then this becomes extremely easy, all right? So once again, the unknown value that we're looking for, we chose to find b first. We're going to put in the top left corner of our first fraction, and then we're going to write the fraction following the sine law pattern. So the letters are the same except one's uppercase at the bottom with the sign. And then on the other side, we're going to set up the same type of fraction, but we're going to put our key values there. And now, since we're looking for little b, we're going to isolate little b. To isolate a variable, we always do the opposite operation of what we're trying to get rid of. So the sine b here is dividing. That means it's going to go over to the other side and multiply. So it's going to look like this. And now we can start putting in all of our numbers. So little c, way up here, is our 15 miles. Sine c is the 80 degrees that we calculated earlier from our 180 relationship. And sine b, well, which angle is b? That's angle 45 degrees up here. And now we just use a calculator to calculate all that. So let me pull up my calculator here. So we're going to do 15 divided by, and on this calculator I have to do 80 and then press sine. Making sure my calculator is in degrees, by the way. You should always make sure your calculator is in degrees. And then I'm going to multiply that by 45. Sine. Now if you have a newer style calculator, you should be able to put sine 45 in that order. Notice that that's how it wrote it here in the window. It's sine 80 and sine 45, even though I had to press 45 first and then press sine. And now I'm not done yet. I have to press my equals button to get the final answer, which is 10.77, which we're going to round to 11 here. Miles. And that's the distance for B, but now we've got to compare that to the other distance to see which one's closer to the port. So that's going to be letter A. So in this case, I'm going to write A over sine A. And again, I'm going to put my key here, C over sine C. So once again, put the unknown in the top left, and put your key values in this fraction. Now we're going to isolate, but at the same time, this time I'm going to substitute the numbers in, okay? So little c over sine c are the same values we had before, so 15 over sine 80. And we're going to multiply by sine A. A being our other angle of 55 degrees. And I'm going to type all those into my calculator. This I'm just going to do off screen if that's okay. And I'm getting an answer of about 12.5 miles. And the question, we'll go read the question again, which one is closest to C? So that means that B is closest to C. Actually, I should probably be using a capital B here since the boat was at an angle, right? Sorry, my mistake. A would be closest to C. Length little b is shorter. So you got to be careful here. Length little b is shorter. That means that A, the boat A, is closest to C. So it's always good to reread the question, make sure we're answering it correctly. And that's basically the sine law. So let's look at another example. So the first thing you want to look at is this a right angle triangle? So step one, is it right angled? And the answer is no. Okay, so that means no Pythagorean theorem, no, so can't use Pythagorean theorem or SOHCAHTOA. Okay. The second thing you want to check is, do you have a key for the sine law? So do we have a side length? Yes. Do we have an angle across from that side length? Yes. So there's our key. And in this case, they're just asking us to calculate length A. Okay, so they're not asking us to solve the triangle. They're just asking to find little a. So let's write out the sine law. So it'll be little a over sine of big A. And what's our key letters? Our key letters are C again in this case, so little c over sine C. So my unknown went in the top left, and my key values went in the second fraction. So let's isolate little a. So that means sine big A is going to move over to here. I'm going to start filling in the numbers at the same time. So little c is 20 over sine of big C, which is 27. And we're going to multiply that by sine of big A, which is sine of 93. And in this case, I'm going to let you type that into your calculators to find the final answer. Okay? So just type it into your calculator and see what answer you get. Now there's also another use for the sine law. And I'm going to skip this slide and just go to this one. The other use for the sine law is to find angles. So same questions as before. Do we have a right angle triangle? No, we do not have a right angle triangle. Do I have my sine law key? Yes, I have my sine law key. But in this case, we're looking for an angle. We want you to find angle X. Well, we're going to follow what I had said before, that your unknown always goes in the top left. Well, my unknown in this case is angle X, but angle X has to always be next to sine in the equation. So what we're effectively going to do is we're going to flip our sine law upside down. Instead of writing little x over sine big X, we're going to write sine big X over little x. And we're allowed to do that because they're two fractions equaling each other. So our key values here are the z values, right? So we're going to do sine of big Z over little z. And to make my z's different, I'm going to make the little z very small, okay? So if you're looking for an angle, or when looking for an angle, flip the sine law fractions upside down. And make sure your unknown is in the top left corner. Now this is going to cause us one small problem at the very end. So let's isolate for big X. So you'll notice that to isolate for big X, we actually have to first isolate for sine big X. So the little x is going to go over to the other side. It's dividing on this side, so it's going to come over here and multiply. Now, I'm going to change the multiplication symbol to a dot here because there's way too many x symbols here. Okay, so let's fill in our numbers. So we've got sine big X is equal to sine Z. Z is the angle, so 33 degrees, divided by little z, which is 18, times little x, which is 27, and I'm going to do this off to the side on my calculator. Sine 33 divided by 18 times 27. And we're getting a really weird answer. We're getting 0.816, and it actually continues 9585. Okay. Now, why is it giving us this kind of weird decimal like this? Well, that's because we're not done yet. This is a sine x equation. And sine x is a ratio. So our ratio is going to be a number that's going to be some sort of weird decimal like this. We have to do one more thing to get x all by itself. And like we saw in previous lessons, in order to isolate x, we have to arc sine both sides. And the symbol for arc sine is sine negative 1. I'm not going to go through all of that again since we've already seen it, but essentially what you're doing is you're going to sine negative 1 both sides, but when you sine negative 1 sine x, it just gives you x. You're doing an anti-function to a function which destroys the sign and just pulls out what's inside the equation, which is x. On this side, we're going to type this into our calculator. Now I want to explain something here. We technically don't want to round that number off, so let me go back to my calculator screen here. And I want to show you that I just kept the answer right on my calculator screen. Look at all of the decimals. If I round that off, I'm losing a heck of a lot of precision on my calculator. So what you want to do, there's two options. On this calculator, you keep, and the older style calculators that don't show you all of your steps in the window, you keep that number on the screen and you just press the second sign button and it'll immediately see it swallowed up that whole decimal number inside the bracket here. So sine negative 1 affected that whole decimal, and now we would round it off to whatever we want to, which would be 55 degrees. If you have a newer style calculator, what I want you to use, and I'm actually going to write it in the note because this is what most of you are going to do, you're going to use your A and S button if you have a newer style calculator. So you would actually do sine negative 1 of A and S. And what that's going to do is put the previous answer, which was that entire decimal, into the arc sine, and that's going to give you your 55 degrees. We rounded that off to 55. And that just keeps a lot more precision to your answer by doing it that way. So let's just recap what's different with finding angles compared to finding sides. Because we were looking for an angle in a non-right angle triangle, the first thing we checked is, do we have our Sine Law Key? And yes, we do. We have an angle opposite a given side. We were looking for an angle, so we put that angle in the top left position of our fraction format, which means we had to flip our fractions upside down. So when you're looking for an angle with the sine law, flip the sine law fractions upside down. Then we did our isolation like we normally do. We tried to get the little x away from the bottom here to get our big X all by itself, so it goes over here and multiplies. We substituted all of the numbers in, and then we used our calculator to find the answer to that, which gave us a pretty ugly looking decimal value. And we have to expect that anytime we're looking for an angle with the sine law, because we still have to arc sine both sides. So we arc sined that number, and we ended up with our angle. And that's going to be it for the lesson today. Sine law for sides, sine law for angles. Hope you were able to follow that okay. If you have any questions, please let me know, and I'll talk to you soon.